All right, let's take a look at number two. So again, thinking about the process, the very first thing I need to do is just kind of make the realization about what I'm being asked to prove. So what I'm being asked to prove here is that the two triangles are congruent. So immediately, since I'm proving or trying to prove triangle congruency of ABC, which is AB over to C, and then EDC, so E down to D over to C. So I know that's what I'm actually trying to prove. Uh, and since it is triangle congruency, the first thing that should pop in my mind are the conditions I could use for proof. Again, these conditions exist simply to shortcut what we actually have to prove. So I'm now proving six sets of information. I can reduce it just down to three. So I'm trying to prove triangles congruent. I have to meet those conditions. Let's talk about the givens. Let's mark our diagram, and at least let's see if we get a better sense of what we actually have to work with here. So first of all, I'm given a side length set, A, B, and ED. So I'm going to mark them A, B, bam, ED. I see that C is a midpoint of BD. So by definition of midpoint, I know that these guys have to be congruent. And then I'm given kind of this weird statement. AB is perpendicular to BD. So AB perpendicular. So we have, sorry, AB perpendicular to BD. Definition of perpendicular tells us that that guy is right. Okay. And then we have ED perpendicular to BD. So we have ED and BD. So that guy is right as well. So now the question is, well, what do I have? Do I have enough here to actually prove it? Can I meet one of these conditions? Well, let's take a closer look. Here I have a side and another one. And then I have an angle which is right, another angle which is right, and then a side and another side. So it seems to me we actually meet that side angle side condition. So in terms of planning out this proof, if I want to prove triangles are congruent by side angle side, I have to be able to identify a side, an angle, and a side in both triangles that are congruent. So it seems to me that we have side 1, which is given to us. We have angle 1, and if you think about how we actually proved that, that was by definition of perpendicularity. And then we have side 2, which came from the definition of midpoint. Okay. So if I combine these three pieces of information, that should give my triangle congruence. So this is going to be my general plan for the proof. I'm going to prove one side because it's given, one angle using the definition of perpendicularity, and maybe some other stuff, and then another side because of the definition of midpoint. So if you watch the last proof, I made a point to make that one using a flow style. So I'm going to do this one a little bit differently. I'm going to use something called a two-column proof. So two-column proofs are actually going to look a lot like the ones we did when we wrote the whole if-then statement, kind of in a row. But what we're not going to do though is write the entire if-then statement. Just like with a flow proof, the important part of the proof is actually the conclusion part. We're still assuming the hypothesis is happening, but we're going to actually just record the conclusions. So to set us up to do this well, being called a two-column proof, and you analytics out there are going to love this, let's set us up using with a two-column table. Let's label it left side justifications, and let's label the right-hand side. Oh, excuse me, that's completely wrong. I messed up, and I apologize. I got ahead of myself. Let's label this side statements, and that's going to be like our conclusions, and then these are going to be our justifications. And I guess nothing but tradition will prevent you from writing it the other way, but that's just that. So we're also going to do some kind of additional labeling that's kind of unique to these triangle congruency proofs. So the first thing I think we need to try to prove is going to be side 1. So let's just get into it. So side 1 is actually given, so the statement I can actually make, because we're using the given side, is actually right up here. So we have AB congruent to ED. And if I want a justification on this side, which I'm going to label as well, the justification is actually just going to be, because it's given to us, it's in the diagram. It's not something we have to justify, it was actually handed to us on a silver platter. So what I'm going to do over here, because we actually have now proven the side length is right, I'm just going to mark it with a little bracket and that's 1, just to kind of help me track my work and what I'm doing. So let's move on. Let's keep on going. So now the next thing we have to prove are the angles being congruent, and we're going to do so because of definition of perpendicularity. Now we can't jump there because if I simply say these two things are perpendicular or equal because they're perpendicular, that doesn't actually explain how I knew they were perpendicular in the first place. So what I'm actually going to start with is the given statement. So I have AB perpendicular to BD and ED perpendicular to BD. And the reason I can actually write that into my proof is again because I have it given to me. So this is kind of like an if-then statement. So if AB is perpendicular to BD and ED is perpendicular to BD, then what can I claim? Well, I can claim then, by the definition, that we have some right angles. Now, instead of naming them with a typical convention, I'm going to come up here and actually just relabel them as angle 1 and angle 2. This is something that's okay to do in proofs. You're able to rename your angles however you want to rename your angles. So instead of calling like this angle that I just called 1, instead of calling this guy angle ABC, I can simply refer to it as angle 1 and save myself some writing. Same as true over here. I could call this angle angle 2, or I could just say this angle EDC and move on my merry way. But anyway, back to the proof. If those angles, if these are all perpendicular intersections, I can then claim that angle 1 and angle 2 are right angles. And the reason I can claim that is because it's a definition of perpendicularity. Again, that's why I said I was going to use in my plan. Now we still aren't done because we're not done until they're actually congruent, but we're getting closer. So again, it's like an if-then statement. If angle 1 and angle 2 are right, I can claim that the measurement of angle 1 and the measurement of angle 2 are both 90 degrees. And the reason I can claim that is because that's a definition of right angles. So we're getting closer. We're not done, and the reason we're not done has everything to do with the fact that these still don't say angle 1 is congruent to angle 2, which is what we need for our actual angle statement. But again, we're getting closer. So we both have them both equal to 90. Well, hold on. If they're both equal to 90 degrees, okay, we should be able to claim that angle 1 is equal to angle 2. So if you're wondering how I did that, it's all about transition. One angle is equal to 90. 90 is equal to the second angle, therefore they're equal to each other. That is a pure dose of transitive property. Okay, so if they're equal in measure, that tells me that angle 1 has to be congruent to angle 2, and that's because of the definition of congruency. And that's a biconditional definition, but it's a definition nevertheless. So we're getting really close here. We now have angle 1 locked down. So let's review our plan. We said that we wanted to prove this by side angle side using one side that was given, one angle that went through the definition of perpendicularity, and it looks like my last side, which I'll mark in green, my last side here is going to be by the definition of midpoint. So if I look at my given, I know C is a midpoint of BD. It's that guy right there. And by the definition of midpoint, that means BC and CD have to be congruent. BC being this guy and CD being that guy. Okay, so I can reflect that. So number 7, step 7, BC congruent to CD. And the reason we know that is because of the definition of midpoint, okay, which then gives us our second side. So if I have now met my conditions, I have side, angle, side. So my very last statement of this proof is going to be triangle, and let me review, triangle ABC, and I'm reading right here, boys and girls, is congruent to EDC. So ABC, EDC. And that's going to be because of side, angle, side, triangle, congruence theorem. And then I will end my proof. Okay, so just a really quick review here. We looked at the diagram and determined, whoa, hello diagram. We looked at the diagram and determined that we could prove these are congruent using one of these four conditions by evaluating the givens and then putting them back into the statement, or I'm sorry, augmenting our diagram. We can see that AB congruent to ED, and then with the definition of midpoint and the definition of perpendicularities, um, will give us side angle side. We wrote a really quick kind of plan, a brainstorm, an outline, if you will, that says, well, one side is given, one angle will result with the perpendicularity, and then another side is going to be from the definition of midpoint. And all those things were actually given to us at the beginning. So we wrote a proof in two-column format, and two-column format's nice because it's very organized. But we're doing some augmenting off to the left just to make sure that to ourselves that we're meeting the side angle side condition. So we said one side was going to be the result of a given, and that's going to be the pink. We had one set of angles resulting from perpendicularity. And again, it's not that simple, and that's kind of like this unbroken chain of logic that's necessary in proofs. Like you have to show why they're congruent, not just like, oh, they're perpendicular, so of course they're congruent, right? Nudge, 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 nudge. No, you have to show it every single step. If they're perpendicular, then they're right. If they're right, then they equal 90 degrees for measure. If they both equal 90 degrees, then the measurements are the same. If the measurements are the same, then they're congruent. And all those steps are completely necessary because right now there's no one on this planet who can question or ask me why those angles are congruent because I left nothing to the imagination. I didn't skip any steps. So starting with what they gave me to how it ended, I have every single thing in there. The last side was a result from the definition of midpoint because it was defined in our givens to be a midpoint. And then since I have side angle side, boom, there's your angles, right? So there's proof number 2. We have quite a few more to go, but if you're watching these, hopefully you're getting these. And again, don't be afraid to pause. Don't be afraid to watch it again. That's the whole lovely part about these videos. You can watch them over and over again.